Hello everyone. In this video, we will learn about heat transfer and its different mechanisms. Understanding these methods of heat transfer is crucial in fields like engineering, meteorology, and everyday applications such as cooking and climate. The process by which thermal energy is exchanged between different objects or regions with different temperature is heat transfer. Heat is transferred through three main mechanisms: conduction, convection, and radiation. Each of these mechanisms plays a role in how heat transfers from one place to another. Also, you should notice that these mechanisms of heat transfer are often present at the same time in various scenarios. Conduction is when heat transfers through direct contact between objects with different temperature. In this process, heat energy is transferred from the hotter object to the cooler one through molecular collisions. The object with higher temperature has molecules with higher kinetic energy, so molecules transfer their energy to molecules with lower kinetic energy in the cooler object. Conduction works best in solid because their molecules are closely packed and can easily pass vibration, especially those with good conductivity like metals. Here is a simple example of conduction. Imagine you're holding one end of a metal rod with your hands, and the other end of it is on a flame. As the heated end of the rod is exposed to the flame, heat is conducted through the rod to the cooler end where you are holding it. The heat from the flame causes the particles at the heated end to gain energy and vibrate more rapidly. These particles, which have higher energy, are in touch with the adjacent particles and transfer these energy to the adjacent particles. After a while, the particles near your hand also gain kinetic energy and vibrate faster, causing an increase in the temperature. Here, conduction is the mechanism responsible for increasing the temperature in all parts of the rod. Convection is the transfer of heat through fluid. As the temperature of a fluid increases, its density decreases, causing it to go up, whereas the colder and denser fluid goes down in your space or container or room. This creates a cycle of movement known as convection current, more specifically free convection. Convection is responsible for the way heat is distributed within fluids and plays a significant role in natural processes like atmospheric circulation and ocean currents. Imagine you're heating a pot of water on a stove. As the water gets hotter, convection currents starts to form in the pot. The bottom of the pot, which is in direct contact with the heat source, becomes very hot. This heat is transferred to the water molecules at the bottom of the pot. These water molecules gain energy and become less dense, causing them to expand and rise. As these warmer, less dense water molecules rise, they create a convection current. Cooler water from the top of the pot moves down to take their place. This creates a cycle where warm water rises, cools down as it moves towards the top, and then descends to the bottom to be heated again. Through this process, water in the pot comes to a almost uniform, rather than just being heated at the bottom. The third mechanism is radiation. Radiation is the heat transfer via electromagnetic waves such as infrared radiation. Energy transferred by radiation is also called thermal radiation to distinguish it from electromagnetic signals. All objects whose temperature is above 0 Kelvin emit and absorb electromagnetic radiation. Objects with higher temperatures emit more radiation, and those with lower temperature absorb this radiation, causing their temperature to rise. Think of being outside on a sunny day. Although you and the sun are not in a direct contact, you can feel the warmth of the sun on your skin. And that's due to the process of radiation. The sun emits electromagnetic radiation, which is a type of energy. This radiation includes visible lights and infrared radiation and reaches Earth by traveling through space. Then it interacts with objects on the Earth like your body. Your body absorbs this radiation and the kinetic energy of the molecules in your skin increases and make you feel like your skin is getting warmer. Or consider when you are close to a fire. You can feel the heat radiating from the fire while you are not in direct contact with the fire. This heat transfer is also through radiation mechanism. This is how we can calculate the rate of magnetic radiation emitted from an object, where sigma is the Stefan-Boltzmann constant, epsilon is the emissivity of the object surface that depends on the composition of the object and has a value between 0 and 1. A is the surface area of the object, and T is the temperature of the object in Kelvin. Be careful, Kelvin. A black body is an idealized object that absorbs all radiation that falls on it, and it also emits radiation at all wavelengths. A black body has the maximum emissivity of 1, and the emissivity of all other surfaces is less than 1. But of course, a real-world object cannot be a perfect black body. We came to the end of this video. I hope this video has provided valuable insight and expanded your knowledge.